Welcome to this lesson on standard form. In science and mathematics, we often work with numbers that are extremely large or extremely small. For example, the distance between planets may involve millions or billions of meters. The diameter of an atom may involve many zeros after the decimal point. Writing such numbers in ordinary decimal notation can be inconvenient and may lead to mistakes. Standard form provides a shorter and clearer way to write these numbers. In this video, we will learn the definition of standard form, its main rules, how to convert numbers into standard form, how to convert them back into ordinary form, and how to perform calculations using standard form. A number written in standard form has the structure a times 10 to the power n. In this expression, a is a number greater than or equal to 1 but less than 10. Therefore, 1 is less than or equal to the absolute value of a, and the absolute value of a is less than 10. The letter n represents an integer. An integer may be positive, negative, or 0. The number is called the coefficient, and n is called the exponent, or power. For example, 3.5 times 10 to the power 4 is written in standard form because the coefficient 3.5 lies between 1 and 10. However, 35 times 10 to the power 3 is not written in standard form because the coefficient 35 is greater than 10. To understand standard form, we must first understand powers of 10. A positive power of 10 represents repeated multiplication by 10. For example, 10 to the power 1 is 10, 10 to the power 2 is 100, 10 to the power 3 is 1000, and 10 to the power 4 is 10,000. A negative power of 10 represents division by 10. For example, 10 to the power minus 1 is 0.1, 10 to the power minus 2 is 0.01, 10 to the power minus 3 is 0.001, and 10 to the power minus 4 is 0.0001. Positive powers of 10 are usually used for large numbers. Negative powers of 10 are usually used for numbers between 0 and 1. Let us convert a large number into standard form. Consider 4,500,000. First, place the decimal point after the first non-zero digit. This gives 4.5. Next, count how many places the decimal point moved. The decimal point moved 6 places to the left. Therefore, 4,500,000 is equal to 4.5 times 10 to the power 6. The exponent is positive because the original number was greater than 10. Consider another example, 728,000. Move the decimal point so that only one non-zero digit remains before it. This gives 7.28 times 10 to the power 5. One more example is 9 billion. This becomes 9 times 10 to the power 9. The coefficient is exactly 9, which satisfies the condition that it must be at least 1 but less than 10. Now consider numbers smaller than 1. Take the number 0.00072. Move the decimal point to the right until the first non-zero digit is immediately before the decimal point. This gives 7.2. The decimal point moved 4 places to the right. Therefore, 0.00072 is equal to 7.2 times 10 to the power minus 4. The exponent is negative because the original number was between 0 and 1. Consider another example, 0.000056. Moving the decimal point 6 places to the right gives 5.6. Therefore, this number is equal to 5.6 times 10 to the power minus 6. Another example is 0.0093, which is equal to 9.3 times 10 to the power minus 3. There are several important rules for writing numbers in standard form. First, the coefficient must be at least 1 but less than 10. For example, 6.4 times 10 to the power 7 is correct, but 64 times 10 to the power 6 is not in standard form. Second, a large number normally has a positive exponent. For example, 320,000 is equal to 3.2 times 10 to the power 5. Third, a number between 0 and 1 normally has a negative exponent. For example, 0.00032 is equal to 3.2 times 10 to the power minus 4. Fourth, the sign of the original number is retained. For example, negative 56,000 is equal to negative 5.6 times 10 to the power 4. Finally, 0 cannot be written with a unique standard form exponent because 0 times 10 to the power n is 0 for every integer n. We can also convert numbers from standard form back into ordinary decimal form. Consider 3.4 times 10 to the power 5. The exponent is positive 5, so move the decimal point 5 places to the right. Therefore, 3.4 times 10 to the power 5 is equal to 340,000. Now consider 6.2 times 10 to the power minus 4. The exponent is negative 4, so move the decimal point 4 places to the left. Therefore, 6.2 times 10 to the power minus 4 is equal to 0.00062. Another example is 8.01 times 10 to the power 3, which is equal to 8010. The decimal point moves 3 places to the right. To multiply numbers in standard form, multiply the coefficients and add the exponents. Consider 3 times 10 to the power 4 multiplied by 2 times 10 to the power 5. Multiply the coefficients. 3 times 2 is 6. Add the exponents. 4 plus 5 is 9. Therefore, the answer is 6 times 10 to the power 9. Now consider 4 times 10 to the power 3 multiplied by 5 times 10 to the power 2. Multiplying gives 20 times 10 to the power 5. However, the coefficient 20 is not between 1 and 10. Rewrite 20 as 2 times 10 to the power 1. Therefore, 20 times 10 to the power 5 becomes 2 times 10 to the power 6. The final answer is 2 times 10 to the power 6. To divide numbers in standard form, divide the coefficients and subtract the exponents. Consider 8 times 10 to the power 7 divided by 2 times 10 to the power 3. Divide the coefficients. 8 divided by 2 is 4. Subtract the exponents. 7 minus 3 is 4. Therefore, the answer is 4 times 10 to the power 4. Now consider 6 times 10 to the power minus 3 divided by 3 times 10 to the power 2. The coefficient becomes 6 divided by 3, which is 2. The exponent becomes minus 3 minus 2, which is minus 5. Therefore, the answer is 2 times 10 to the power minus 5. Addition and subtraction require special care. The powers of 10 must first be made equal. Consider 3 times 10 to the power 5 plus 2 times 10 to the power 5. Since the powers are already equal, add the coefficients. 3 plus 2 gives 5, so the answer is 5 times 10 to the power 5. Now consider 4 times 10 to the power 6 plus 3 times 10 to the power 5. The powers are different. Rewrite the second term using 10 to the power 6. 3 times 10 to the power 5 becomes 0.3 times 10 to the power 6. Therefore, 4 times 10 to the power 6 plus 0.3 times 10 to the power 6 gives 4.3 times 10 to the power 6. Similarly, 7.5 times 10 to the power 4 minus 2.5 times 10 to the power 4 gives 5 times 10 to the power 4. The exponents must match before the coefficients are added or subtracted. One common mistake is writing a coefficient greater than or equal to 10. For example, 12.5 times 10 to the power 4 is not in standard form. It should be written as 1.25 times 10 to the power 5. Another mistake is using the wrong sign for the exponent. For a small number, such as 0.0008, the exponent must be negative. Therefore, 0.0008 is equal to 8 times 10 to the power minus 4. A final common mistake is forgetting to match exponents before addition or subtraction. Standard form provides a compact way to represent very large and very small numbers. A number in standard form is written as a times 10 to the power n, where the coefficient is at least 1 but less than 10. Large numbers use positive exponents, while small numbers use negative exponents. When multiplying, add the exponents. When dividing, subtract them. When adding or subtracting, first make the exponents equal. Standard form is widely used in mathematics, physics, chemistry, astronomy, engineering, and computing. Thank you for watching.